In the bustling world of computer systems, processes are constantly vying for attention. A process, simply put, is a program in execution. It's like a chef juggling multiple dishes at once in a busy kitchen. To manage this intricate dance of processes, operating systems rely on a crucial tool, the Process Control Block, or PCB. Imagine the PCB as a chef's recipe card, holding all the essential information about a particular dish. Similarly, the PCB serves as a container for all the vital data associated with a process. Whenever a process is created, the operating system creates a corresponding PCB to keep track of it. This information is crucial for the operating system to manage processes effectively, allocate resources efficiently, and ensure the smooth execution of programs. Without PCBs, our computers would be like kitchens in chaos, with dishes half-cooked and orders lost in the confusion. Operating systems are the masterminds behind the scenes, coordinating the hardware and software to ensure everything runs smoothly. One of their most critical tasks is process management, which involves handling the creation, execution, and termination of processes. This is where PCBs come into play as the unsung heroes of computing. Think of the operating system as a conductor of an orchestra, and each process as a musician playing an instrument. The PCB is like the conductor's sheet music, containing all the necessary information about each musician and their part in the symphony. Without PCBs, the operating system would struggle to keep track of which processes need which resources, leading to conflicts and crashes. These little data structures are essential for multitasking, allowing our computers to seamlessly switch between different tasks, making them responsive and efficient. Just like a chef's recipe card contains ingredients, cooking time, and temperature, a PCB holds a wealth of information about a process. Let's delve into some of the key components and their significance. Process ID. This is a unique identifier assigned to each process, much like a passport number. It helps the operating system distinguish one process from another. Process state. This indicates the current status of a process, whether it's running, waiting for a resource, or terminated. Think of it as the stage a dish is in, being prepared, cooking, or ready to serve. CPU registers. These are small memory locations within the CPU that hold the current values being used by the process. They are like the chef's hands, actively involved in the cooking process. Memory management information. This section stores details about the memory allocated to the process, including its location and size. It's like knowing which pots and pans are being used for a particular dish. Scheduling information. This includes data about the process's priority and any scheduling algorithms being used. It's like deciding which dish to prioritize based on its complexity and readiness. I/O status information. This section keeps track of any input-output operations the process is performing, such as reading from or writing to a file. It's akin to knowing if a dish requires additional ingredients from the pantry. Imagine you're browsing the web while listening to music and writing a document. Each of these tasks is a separate process, and the operating system relies on their respective PCBs to manage them effectively. The PCB for the web browser will hold information about the current web page being viewed, the network resources being used, and the priority assigned to it. Similarly, the PCB for the music player will contain data about the song being played, the audio output device, and its scheduling information. When you switch between these applications, the operating system uses the information in their PCBs to seamlessly transition between them, ensuring that each process receives the necessary resources without interfering with others. This intricate dance of processes, orchestrated by the operating system using PCBs, is what enables our computers to perform multiple tasks concurrently without missing a beat. From browsing the web to playing games and running complex software, PCBs are the unsung heroes working tirelessly behind the scenes to keep our digital lives running smoothly.